My name is Derek Weitzel, and I'm going to be presenting the Science Gateway for Biological Nanotechnology. Now, a few introductions. I'm an assistant research professor in computer science, and I work with researchers at UNL and on the Open Science Grid to enhance their science with computational resources. This project will also work with an assistant professor in chemistry, Dr. Joseph Yesselman. He's interested in the structural basis of RNA functions and how to design new RNA nanostructures and machines. Now, HCC is the Holland Computing Center, and we are Nebraska's research computing resource. We provide Nebraska's researchers with computational, storage, and other resources. And here's a picture of our supercomputers in the basement of Shore Center, and also one of our older displays showing our network traffic to other sites in the world. Now, there is an emerging field that Joseph Yesselman is a part of for RNA nanotechnology. And you may have heard of RNA, especially this graph on the right. RNA can be used to control specific proteins and whether they're generated. In fact, RNA was one of the ways that vaccines for COVID were created using messenger RNA to create specific proteins that could be detected by your immune system. But RNA can also be used in other ways. They can destroy disease state with RNA messages, as well as many other uses. But RNA nanotechnology requires precise control of the RNA structure. So you have to assemble it very specially, and it's critical to create these new machines, RNA machines, very specifically for their applications. So the Yesselman lab has generated a suite of software that they call RNA Make that can automatically assemble these new nanostructures. And this is a diagram on the bottom that shows how this suite of software can generate this RNA structure. Now, RNA Make is a powerful tool for designing RNA nanostructures. It can be used to model it. It can be used to simulate the docking of the RNA, and this all improves the ability of RNA to do things like sense drug-like molecules. Now, the goal of this project is to enhance a gateway. So a gateway is a user interface for scientists to submit to research resources, such as computing or storage. And the goal of the gateway is to provide an easy-to-use interface for researchers to utilize computational resources. Now, results should be presented back to the user in a format that's readable and usable. And so here's an example of a gateway, the BLAST gateway from the National Institutes of Health. You'll notice that they have input parameters. They include some files that you can upload. The processing is all done on some backend server or some cloud that the user doesn't know about, that the user just knows that they submitted their jobs and they'll come back eventually to usually to their emails. Now, there is a current gateway that was designed last year, the RNA Make 3D using the RNA Make 3D design toolkit. Now, the current gateway can submit to the Open Science Grid, which is a national resource for computational uses, but the interface for users is not customized enough for RNA Make users. For example, if you look at this is the input for an RNA Make experiment. Now, I apologize, the screen is kind of big, but what you'll notice is that this isn't really guiding the user through inputting the data. It's not interactive. You know, you submit the file for the RNA, and you have to specify the starting base pair. You have to specify how many number of designs. It's not interactive. When you upload the file, it won't show you the structure that's already that's in the file. It definitely doesn't have that interactivity that's needed to guide the user through submitting this job. Now, for this new gateway, the technologies choices are your own. I expect that there will be HTML, JavaScript, CSS. I expect that there will be uh, you'll have to connect to the API in the back, which has a Python API. Um, the front end needs to be significantly redone in order to guide the user through submitting the jobs. And then we have another application. We only had one application in the gateway last year, and this year we have another application which has different input, and we'll need to be able to customize this input. So the objectives and deliverables for this project is a new gateway to submit this processing. The emphasis is it should be intuitive and interactive for the user. Now the design choices are, of course, the groups. But we do want it to be interactive. We want it to be intuitive and to guide the user through the submission page. Will have a home page, a submission page, a processing status page, so they can see what the status of their processing is while it's on the Open Science Grid. A results page, which will be sent to the user through email when the results are completed. That is our project, and I hope to work with you soon.